So let's quickly do a couple examples on changing from Cartesian to polar. We have z, some number is equal to 1 plus 2i. Let's sketch this out really quickly on a complex plane. We have 1 here, and 2 there, theta, and so to get the magnitude, we just use Pythagoras, 1 squared plus 2 squared all square root, giving us square root of 5. And then the argument of z, that's the angle, theta. Observing that we're in Q1, we don't have to worry too much about the reference angle versus the actual angle. It's just going to be tangent of minus 1 of y over x, which is 2 over 1. Calculator gave us 1/7. Technically, you can stress that this is plus or minus 2n pi, but we're going to keep this from 0 to 2 pi or negative pi to pi. That's, you can kind of choose your own convention. So then altogether then, the answer turns out to be z is equal to root 5 e to the I 1.107. And that's the answer in polar form, same complex number. Second example. We have numbers like these. This is example 2. Well, this time we have negative numbers. So sketching this out, we have minus 2, minus 3, and theta goes like that. Notice how we're in Q3. So with Q3, we have to be a little more careful about our angles. So magnitude we still get the same way, which is the square root of 2 squared plus 3 squared, square root of 13. And then the argument of z has to be pi plus the inverse tan, because the reference angle is only giving us from 0 to pi over 2. And that altogether gave us 4.124. You could of course express this as 2 pi minus 4.124. Sorry, my bad. It's 2.124 minus 2 pi to give you a negative answer if you want it from negative pi to pi, which is negative 0.158. So you can either express this final answer as square root of 13 e to the I 4.124 or root 13 e I to the negative 2.158, depending on which convention you would like to follow.